Welcome. So we're going to answer this question before us. It says, a path cuts across a park. Its center line can be described by this equation here, where the origin is at point 0 in the park. The path starts here and finishes there. First thing says is how long is the path? So we're going to use our distance formula here. Take note of the 2 points that we've been given. So we've been given -30, -15. And we've been given 60, 30. So remember the way that we use our distance formula is we say the distance is equal to the square root, then we subtract the x values from each other. So it's going to be 60 minus 30, which is plus 30. And then it's going to be 30 minus 15, which is going to be plus 15. And then you square it. Now it's just a matter of chucking that into our CAS calculator. So we're going to go control this one. Now that's going to be 90 squared plus 45 squared, which is going to be 45 on the square root of 5. And that's going to be our first answer. Perfect. Next, it says, now let's zoom out a bit here. One boundary of the pond in the park is parabolic in shape. The boundary passes through the points this, and this. The equation of the parabola is in this form. Find the equation of the parabola. So as you can see, this is what we're after, this parabola here. The first thing that we're going to do is come to our CAS and simply define what the form is. So control this. We're told it's a times x squared plus b times x plus c. Make sure you got those time symbols between the b and the x and the a and the x, otherwise it's not going to work. Then we want to go menu, we want to go algebra, we want to go solve system of equations, this one right here, go up, A, B, C. Now, what are we told? We are told that we've got -20, 45. So that means when my x value is -20, this will be 45. Then the next one is 40, 40. 40, 40, that used to be a game we used to play at school, 40, 40. Do people still play 40, 40? I don't know, maybe. 30, 35. All right. Then we hit enter and we get this out here. Okay, amazing. So we're going y is equal to 7 on 600 minus 19 on 60x plus 34. Okay, having now done all of this, we're now going to move on to our next question here. And this question is a bit odd. It's not often where you have to write something down, but still a good question for us to look at and see if we can make sense of it. So let's give it a read. It says, if I can get my highlighter, what does the expression this represent? So as you can see, I'm taking the parabola. This right here is the parabola. And this right here is a straight line. And these both represent something in our example, okay? This represents the path, this represents the pond. So that means this is the pond, and this is the path. And I'm subtracting them from each other. And when you're doing this, what you're finding is you're finding the perpendicular distance. And let me be a bit more precise here. You're finding the distance between the pond and path, which is perpendicular to the x-axis, Now let me just make sure I don't misspell perpendicular. Perpendicular to the x-axis. So that's what you're doing. And let's just consider this for a second. So let's come up here. For instance, if I take this point and I subtract away this point, would you agree that I'm finding that distance right there? And that distance, if we were to just continue it down, is at right angles to the x-axis. So we're just finding the distance. If I take that point and I subtract them, I'm finding the distance. Now this is important because then the next part of this question says, find the minimum distance between the path and the pond and the value for x for which this occurs. Okay, so what that means is I'm going to come to my CAS and I'm going to, okay, all right, I'm going to take this x squared plus this x plus 34, and I'm subtracting from that x on 2. Oops. X on 2. Now you have to be careful because now this shouldn't make a difference if I put that. That's all right. I can just do that. Perfect. And I'm going to get that out there. Now if I graph this, control that graph it. And just to take actually, let me just sort this out first. Menu, window zoom. Woo. Let's zoom out. There it is. And just people might be wondering, how is it that I got this here? All I did is I took this and I went Control C, and then I just went Control V. Your CAS is a computer. Treat it as such. Okay, I want to find the minimum distance. It's just going to be this point here. So this is saying, you know, when X is this value here, I'm going to get a minimum distance. So menu, analyze, minimum from here to here. Now this is where some people will get, will do something incorrect. They're going to leave their answer as 19.708. But you see how, and I'm going to write this in here. I'm going to say, note, answer must be exact because decimals are not specified. Okay, so I must provide an exact answer to this. So what is the exact answer to this going to be? What is my exact answer? Well, you can see that X is going to be equal to 35. So that's great. Because it does say for what value of X does this happen, but what's the distance going to be? Well, the distance is going to be this Y value here. And you might be asking yourself, well, how can I figure out what the exact value of 19.7083? Unfortunately, in the graph portion of your calculator, you can't make it exact. But there are a couple of ways we could go about this. Now, it just so happens that this 35 is, you know, an exact value. So we could come over here, we could take this value and go, well, control that such that X is equal to 35. And we will get 473 on 24. Another thing we could have done, if you want to find the turning point of something, you could just complete the square. You could go menu, you go algebra, you could complete the square, and then we just want to complete the square of this, enter. You always have to go comma X when you're completing the square, comma X. And as you can see here, there it is, 473 on 24. So that's just another way for you to approach this question. If you wanted to, you could complete the square, but just make a note of the fact that an answer must be exact when the decimals are not specified. Just be careful of that. Okay, I'll see you in the next one.